All sample dataset files are located under sample data folder, which is also located in application directory. There are three types of sample data, from active survey and passive survey and active-passive combined surveys. Active and passive sample datasets are numerical synthetic data created by using the seismic modeling algorithm, which is also part of this software. And this active-passive combined data is a real data collected along the local highway. And all of these sample data sets are already in PS format without source receiver setup. Active sample datasets to generate 1D and 2D velocity profiles were already demonstrated in these two separate video tutorials, and this particular video tutorial will cover passive and active-passive combined sample datasets. In theory, both 1D and 2D receiver arrays can be used for passive survey, but the passive survey using 1D receiver array is identical to this active-passive combined survey. This particular video tutorial will cover these two steps of data processing, and the remaining steps are already demonstrated in these two separate video tutorials. These diagrams illustrate how those passive sample datasets were created through seismic modeling algorithm. These four sample datasets were created by using four different types of two-dimensional receiver arrays, and these yellow arrows indicate incoming direction of modeled surface waves, and each asterisk mark indicates the location of their source point. So each dataset contains 4 instances of surface wave generation, and each successive generations were apart by approximately 2 seconds. The sample data from active-passive combined survey is called RDMASW.DAT. It is a real dataset collected along the local highway, and this type of MASW survey is sometimes called roadside MASW survey. And the data contains total 18 records of 24-channel acquisition collected through conventional roll-along acquisition that used the 10-pound sledgehammer as an active source. So it was basically an active survey to generate two-dimensional velocity cross-section at the end, but the only difference was it adopted a long recording time of 120 seconds. So the recording was triggered by this active source of 10-pound sledgehammer, but it continued for much longer time than normally used in active survey, so that it can capture ambient vibrations, which basically consist of passive surface waves. In that sense, this is called active-passive combined survey. First, go to Setup Source Receiver here, and then from Formatted Seismic Data, and then choose this circle array.dat, and then run widget, and it was passive, and it was a 2D receiver array used, and it was a circular receiver array, so I choose this one, and this one was a channel 1, and this one was a channel 2, and then diameter was 100. Click next, and it shows correct configuration of all the receivers here. So I confirm this is correct and exit. This page is where I can actually assign distance and station numbers for each individual record included in the input file. Because input file had only one record, these specifications do not matter. So I just skip this one and I move to next and then run. And specify output file name, and it's done. So I exit, and parameters are saved, and then it's gonna move to next step, which is a dispersion image generation. Yes. And then I will run dispersion image, because at this stage the program already detected all the parameters, including it was a passive survey and it used the two-dimensional receiver array. So it already sorted out which processing algorithm it has to use. So most of the times all you need to do is just click this run dispersion image button. I'm going to demonstrate how to combine one active dispersion image with another one passive dispersion image. First, I'm going to display active dispersion image. Is this one. And then I go to combine and select one of the passive dispersion image from circular receiver array, which is this one. And then program informs me of different scales between those two dispersion images. I'm gonna proceed anyway. Yes. And most of the default parameters here are sufficient in most cases. Click OK. And this is the overlapping zone, so I'm going to display only for this zone. So I change vertical scale here, change up to 75 Hz. So this is combined zone of dispersion image, and this is after combining, and this is before combining. So with active dispersion image alone, I do not have a clear model interpretation for this zone, but once I combine those two images, I have much better interpretation of dispersion image. I'm going to demonstrate how to combine one passive dispersion image into multiple number of active dispersion images. For example, you have an active data set collected through conventional roll-along approach for the purpose of generating 2D velocity cross-section at the end. And during the active survey, you performed a passive survey approximately at the center of the survey line by using preferably larger dimension receiver array, which is preferably two-dimensional receiver array. And then you process that passive data to produce one passive dispersion image. And now you want to combine that passive dispersion image into all your active dispersion images to provide a constraint at lower frequency side of dispersion pattern, which is related to deeper investigation. So I first display active dispersion image, and I'm going to change the scale here. So as I go through all the active dispersion images, I see that the dispersion images are not well defined. So I want to combine the passive dispersion image process. So here, go to combine, and then select this passive OT. And here, if you go to records, the program already selected this one as checked. Combine imported record to all other records also. So make sure this is checked and click OK. And now this is combined the dispersion image. So as I go into next image of active image, that common passive image is also combined into this active image as well. So as I scroll through different active images, I see now dispersion trends are much better defined.